Before every innovation sees the light of day, and every robot learns on its own. Before every automobile safely drives itself.
Keep right.
And every rocket ship reaches the stars. Before every product is printed out of thin air. And every digital twin prevents a tragedy. Before every baby takes her first breath. And every virtual reality becomes reality. Before every student has the world at their fingertips. And every patient gets his sight back. Before all this can become real, there is a designer, an entrepreneur, an engineer, a student, a scientist, a visionary, tirelessly working to create a better world, using the most powerful, the most pervasive simulation technology on the planet. Before every product delivers on its promise, there is Ansys.
Good morning. I'm Aaron Snell, Enterprise Consultant at Product One Solutions, and I would like to welcome and thank everybody for joining us live today, the latest installment in our online webinar series. And if you are catching this as a recording on the YouTube channel, a warm welcome to you as well. Today we will be covering a topic that has become more and more relevant in a highly competitive market where your customers demand faster time to market, improved quality, and value for money as well. That brings me to introduce today's webinar topic of finite element analysis with Creo Ansys simulation. So before we start, just a quick overview of the agenda for the next 60 minutes. So I'm going to take you through a quick introduction. Then I'm going to hand over to the demonstration that will be done. And afterwards, we will be doing a Q&A, so all your questions. Before we begin, at the end of this, you will each receive a link of the recording. Please share that amongst your colleagues and everybody that you think might find it of interest. Also, if you look at the top of your Teams bar, you will see there's a Q&A section. If you've got any questions during the webinar and the demonstration, please feel free to ask your questions there. We're going to answer them at the end of the session. And then also, we will be holding a poll at the end. Please do take part, and your honest opinion is welcome. Now, in 2018, two leaders in the computer-aided engineering industry, Ansys and PTC, made history when they announced a partnership that will bring their customers a host of innovative solutions with one goal in mind, and that was to accelerate product innovation by providing customers a best-in-class simulation-driven design environment. As we know, Ansys has been offering standalone FEA tools since the early 1970s. But with the partnership, they will bring a fully high fidelity simulation solver and functionality merged with a class-leading CAD design package, and this is called Creo Ansys simulation. Before we get into the demonstration, allow me to give you a quick overview the suite of simulation solutions that PTC offers. Starting with the concept and early design phase, PTC offers the generative design extension that enables users to create optimal designs from a set of predefined design requirements. For example, if you're looking at reducing the weight of a product or design for optimal size and shape, or a specific strength requirement that your product might have. The next solution on the list is Creo Simulation Live, also powered by Ansys. This is the world's first solution where results of your simulation is updated in real time as you make changes to that CAD design. We covered these two solutions in detail with the previous webinar, and I would strongly recommend that those that did not watch them yet to please have a look at the recordings available on our YouTube channel. Next, we will be moving into the final design and simulation phase, where we will go into detail on today's topic and the use of high-fidelity simulation tools. So why do we need simulation software? We need to understand our products and their performance by simulating as close
because he's using the
conditions as possible. This allows us to shorten the development cycles, enabling you to get your products to market faster, reducing the time each design cycle takes, as well as reducing the need for more physical prototypes. Even in some cases, our customers could eliminate them altogether. By using simulation and understanding how your product will perform,
for 1 second.
Warranty liability is reduced and building a strong, reliable brand that can demand a price premium. So that brings us to the introduction of the man that will be doing the demonstration. So it's my honor to introduce Lefuna Sudedada. He's got a B in mechanical engineering from University of Pretoria, and is an application engineer with Product One, focusing in CAD and simulation related products.
Thank you for that, Alan. I see it. All right. There we go. All right. Thank you for that. Ladies and gentlemen, so where do we start? Who uses simulations? Obviously, I'm of the understanding that in the audience here are mostly engineers and designers. It is definitely us who use simulation software. We need to evaluate and validate our designs to make the best decisions for our products. We also need to resolve. We need to also identify and resolve flaws early in the design process. This saves us money down the line as well. We also want to optimize our design, also improving its quality and performance, and thereby reducing its costs. We also need to use simulation to avoid relying on costly prototypes, also which allows us to mitigate the risks of product failure as well as warranty liability and liability. That is, when we push a product out to the market, we are able to have confidence that it is what we say it is. Now, Creo Ansys simulation offers a high fidelity and high accuracy simulation for design, refinement, and validation. That is the combination of Creo Ansys as well as Ansys simulation and Creo, putting it together to give you the best of all, give you the capabilities which are accessible via a familiar Creo user interface. For those that have been using Creo, that means that you get the power of Ansys in your familiar Creo. You can also analyze your model and quickly identify problem areas and update the design and quickly jump back and rerun that one without needing to use a different software package. As I've mentioned, Creo Ansys simulation now has that common consistent Creo, as that common consistent Creo user interface, which means that you have familiar workflow, context-sensitive menus, sidebar commands, which you are already using. Now, it's a benefit in terms of your productivity and also streamline your work. You've got the simulation tree that has been added. This allows you to communicate your design intent with your fellow colleagues and or other stakeholders. You can also use the Creo geometry within Creo Ansys, taking the full advantage of the full associativity between Creo and Ansys. But then what does that mean for you? It means that you speed up your time to market, get your product onto the market that much quicker, which gives you an upper hand against competition. Also means that you design for value. You are sure of your product, and you also increase the quality and the performance of your product when you manufacture it first time around, and also reduce that development time, the amount of time it takes you from concept all the way until manufacturing, as you have those tools right at your fingertips. And of course, the bottom line, which is the return on your investment. All right. So I will be demoing this product for you for today's demo. The scenario is I work for a trailer manufacturing company, and I am working on a chassis. Basically, what I will be doing as an analyst is that I will be validating the design that was created by our designer. Okay, I'm going to jump into the demo now. Yeah. So as Aaron has mentioned, we said that if you have watched our previous demo, our previous demonstration, okay. So excuse me. Okay. As Aaron had mentioned, that for those that managed to join our previous demonstration, they will be able, they've seen that Creo Ansys simulation live. But for those that have not, we strongly advise that you go and see that. So I do apologize, I'm just quickly sorting out my network here. And there we go. All right, so can you see my screen there?
Okay, thank you. All right, thank you for that. All right, my name is Ufuna Shidada, as mentioned, and I'll be taking you through the demo session. So, as mentioned, Creo Ansys is a high-fidelity software that combines the power of Ansys with the usability of Creo Parametric. For those that have used Creo Parametric, you'll know that the workflows that you have within Creo will also continue, and you'll have the familiar workflow when you go into Creo Ansys. So, for those that watched our previous demo, our previous webinars, for those that have not, you are welcome to go and have a look at those. We did one on Creo Simulation Live. So Creo Simulation Live is us giving, or rather is the power of simulation or validation earlier on in the design, giving you the most information to make the best decisions for your design. So by the time it gets to the analyst for validation, you already have taken care of the low-hanging fruit in terms of your design, inside that you have a more robust design because you are more aware of the performance of your design. But of course, you cannot rely on Creo Simulation Live, as mentioned, that it is not as it's not a high fidelity situation. Hence, come in Creo Ansys. All right. So within Creo, you have both live simulation, where you will do your run, and then from that you can actually go into Creo Ansys. So what you should know is that if you run a study in Creo Simulation Live, you are actually able to bring in those loads and constraints into, or rather the simulation studies into Creo Ansys. This does not mean that you are limited in terms of creating those loads and constraints within Creo Simulation Live. No, you are also able to create them in Creo Ansys. For those that use Simulate more often, is that if you would like to use Creo Ansys, you can actually import the study that we created in Creo Simulate and then come and continue, or rather come and do your analysis in Creo Ansys. As you can see, you have the familiar ribbon, familiar model tree, as well as the simulation study tree. In Creo Ansys, it allows you to create 3 different types of studies. That is your structural, thermal, and model. For today, we are going to look at the structural simulation. I also had a model simulation that I created when I was just verifying that all my constraints were fixed the way I would like them to fix, that I don't have any rigid body motion. All right, so you, as I've mentioned, you come and create your loads, your constraints. You have access to your fixed displacement all the way to your support. This now gives you better control in terms of getting your simulation into as close as possible to the real life event. Your loading as well, all the way from forces, gravity, centrifugal, as well as temperature. When Creo Simulation Live comes to, when Creo 9 comes out, you're going to have the option to have multiple studies. Oh, sorry, correction. Actually, no, it's not that. What I meant to say, multi-physics. Yes, multi-physics studies in Creo Ansys 9. All right. So as I was saying, now if we look at our model here, we have a beam that is coming from a chassis truck, which has been loaded according to where the suspension is, as well as, not sure what the correct term is, but those that work with trucks, you will know, is where it rests on with the connection to the actual I'll call it a truck that has the engine, of course. Yes, so this is my model, and I've simulated the loading on top here, which is both the bin as well as some contents in there as well. All right, so what you do have access to is you got access to creating your or specifying your material. You can specify the material earlier on in the design, but for the advantage that you can change the type of material you want to work with, you can also come and add your material on the side as well. So, for example, I wanted to add that mild steel over there, and then I've got that material assignment. Of course, it will add it to where my I have activated. But actually, let me come and activate this one here and have that material assignment. And all right, I have material assignment on the entire one as well. All right, so as it is a high fidelity, you also have control in terms of your meshes, right? So maybe before I get to the mesh, just let you know that you also have access to idealization options to allow you to sort of get your model a bit more lighter and easier to work with, of course. Such as the mass idealizations, you can put in springs, shells, and beams. You can also, for those that are working with simulations that have got that are sub-assemblies or assemblies rather, you have access to creating contacts. You can create those contacts, or you can also select. You have the option to detect contact. You have an option to specify joints and how they behave. This is either your hinges, maybe opening it up might just give you an idea of what those are. You could do hinges, translational slots, as well as you could planner. Or you can create new and you define it depending on not really depending on, but you define them as per you're constraining the different degrees of freedom. Okay. All right. Now, as I said, we're speaking to the mesh. Now you have an option to do the mesh resolution. So basically, when you're at low, it will automatically generate mesh elements that are quite large. When you go on the high, on the other hand, it will generate mesh elements that are quite low. Maybe if I leave it here for now. All right, and then you have access to the global mesh size dialog box, which basically allows you to be able to have user-defined inputs in terms of your mesh elements. You have the size function, which is curvature. Curvature looks at your model and it estimates the size of the element, looking at the curvature of the different element of different features in your model. Proximity, it looks at the gaps that between or the spaces between elements, and it sort of analyzes the size of elements from that. Fixed basically just ignores either your proximity or your curvature and just takes in user input value. So it's almost as if it's saying that the size element will be this, and it does not really bother to find out what type of the feature it is. And then curvature and proximity, of course, it's the combination of the first two. So for the first one, I'm just going to make that minimum element to be 20. My model is about 500. So 300 is a safe bet there. All right, so from there on, I'm going to go ahead and generate my mesh. So as it's running, these are the other ones that I had done before. Right, as it's running, one thing that you should know about is that you actually have the ability to move out of the model. Let's say, for example, I wanted to go and select a different, what you call again this thing, a different model, and then I want to work on that. I actually have the ability to do that. All right, so this is the name. So as you can see, this is sub-assembly. Fortunately enough, this one was a quick run, but it's fine. So this is a sub-assembly as well that I am able to go in and run. Okay. So one thing that you should understand is that you cannot select the types of meshes that you want. Itself analyzes the model, takes in the user-defined inputs. If you have put any on the global mesh side, and it will decide the types of mesh that you're going to get. For example, here we have the triangle one, so the tetrahedral one. For others who have worked with simulating beams, would have expected it to be box type. But like I said, it will analyze the model and it will decide on that. So for example, if we come back to this one, and I'm just gonna go to Ansys here. This is sub-assembly. This is just for us to see that it can actually go ahead and create a mesh for. So I'm just quickly going to exit from the mesh on the other side. Let me just do that quickly and let it load. And that's all right. There we go. Sorry, my mouse just disappeared on me. All right, there we go. Okay, and I can actually jump back to this one and say, all right. Okay, while it loads, there we go. So the blue lines that you see here, as I mentioned earlier, that you can actually do a detect contact. And you can actually have it. This is basically it going to defining the context between all the different paths. But what I want to show you is that for mashing, you are also able to mash the what you call again this thing assembly meshes as well. So my mouse is misbehaving. Let me just that's right. Yeah. All right, there we go. Back, of course. All right, there we go, and then it is created that mesh for you. I'm gonna exit that. I'm gonna go back to our beam, and what we're going to do now is that we're going to sort of make the mesh a bit more finer, and then run a simulation. Let's say I wanted to run with 100. There we go, and then I'm going to run that. And then as it's running, I have access to the process manager, which shows me that information. But I can also have a look at the diagnostics for what is already run. For this one was just generating this one was just generating the number of elements. So it tells me that I have 17,000 nodes and 8,000 elements. Okay, it has run, and when I look at this one here. All right. So for those that have worked with Creo Simulate, the diagnostic window is a bit different this that, and that'll take a bit of getting used to. But the information is there. For example, here is telling you how much memory it is used, how much time it is taken, the number of cores that it is used there, and the way the temporary file for that input is, and how many cores I have, how many it wanted to use, the name of my system information, how many warnings were counted, how many errors were there. See, I have one warning there, and that is the warning that I have. And then from there on, you have the information in terms of the calculations that it ran. Okay, so let's look at the results there. And I have that as okay. That's very interesting. That's all right. Let's have a look at what is standard is reporting there. And okay, so for your basic results, it doesn't really allow you to animate that. That's a lot. So something definitely moved that wasn't supposed to move. So for your basic results, it does not allow you to animate. So what you need to do is come and define what is called an advanced, advanced result. Yes, advanced result. So for example, on this one, I'm going to say I want to add the magnitude as my advanced result. And I add that. I also maybe want to check my displacement in the Y. And I add that. And I already created one for the mices. All right, cool. So now there, it's essentially telling me that these results have not been updated. So for the results, when you define new results, it's already done calculation. All you need to do is to come to, oh, this is not network. All you need to do is basically come to your results, update the result by just right clicking and selecting updates. Okay, it seems that in my clicking hit updated. Let me add this one to show you that again. I'm just gonna add one more and then right click and update the results. Okay, it's loading. There we go. The results have been updated, and then I can actually come and have a look at what is happening here. All right, I see what is happening there. Maybe just something to show you here is in terms of. Okay, there we go. Awesome. So what to do now is for us to fix that one there, which is basically looking at my column regions. They are correct. And oh wait, stop. That's actually a good idea. Okay, let's see and individual surface. And then looking at those that one there and my constraints on the other end on the defined surface. Okay. Quick troubleshooting of the model and voila. Run that again. And then we can see the result. Okay, so it seems that when I updated the constraints, I updated it on the second run and not on the first one, which of course it's a basic, it's a simple issue to record. So that's another thing that you should be aware of, that when you are creating your duplicates, is that you can actually, not really your duplicate, but your different studies, you can actually change how each model is fixed on the different one, which means that you can test different types of concepts, different types of scenarios, and you have access to it. All right, now run. That's what we're looking for, because we know it's fixed at side and it's fixed at side as well. So in Creo Ansys, in Creo 9, what they're going to do in Ansys is that they're going to give you access to scaling, because right now here is the default scaling. This is not exactly what's happening in real life, but it actually tells you where the model is breaking, or exactly where the model is getting the most deflection, rather. All right, so when it comes to Creo 9, you're going to have access to manipulating the scale. Basically, the scale is to what degree do I want this imagined deformation happening. So at this point, it's not there, but it's sure, rest assured, Creo 9 is coming soon. All right, so what we're going to do now is that we want to add a probe. Probe is basically just us targeting a certain point, and we say we want to know what that value is. I think I saw my maximum somewhere around there. So I'm going to have both of those surfaces as part of my thing, mices, and there we go. All right, as you can see there, it says not calculated. This is what happens when you add probe. I just want to change my There you go. So when you add a probe, unlike your simulation live, where when you add a probe, it immediately updates. This one does not. So that means that you need to run the model after create. You need to run the model after you create the probe if you want those results, or you create the probe and then you run it again. In Creo 9, rather, what's going to happen is that if you make changes to your model and you have a probe that has already run, you are going to get flags which tell you that the current value is not up to date. And that means that you need to go and run the simulation again so that you can update your probe. This is just another way that they're adding to make sure that your results are actually up to date. All right, so we are going to run that, but what I also want to do is that I want to drill down on my elements for this run. I'm going to make them face as that, and just simple round numbers, and then I'm going to run. All right, so what runs is what is activated, and when you want to run a different one, you have to activate a different one. Unfortunately, you cannot do a batch run from this interface, but so you're unable to do a batch run from Creo Ansys. All right, cool. So as you can see there, it actually did not take a lot of time. And then this is, of course, because the model is quite small. As you saw with the elements that were generated on the first one, it wasn't that big. But as your models become bigger and much more complex, this is going to take a whole lot more time. So just going to look at those results there. As you might be interested to look at what that match looks like. Decent match over there. And I'm just gonna look at those results. It's giving me about 54, 53, 54. All right, right over there. So what I can do now to just get a bit more information at that point. So I can say, let me just, yeah, that's correct. So local match refinement. I just want to spread those elements just a bit, you know. So I'm just gonna make it 5, just to add a bit more information. What exactly is happening over there? And just going back out and on that simulation again. Is my maximum is actually around where I just got that a bit more refinement, of course, which is what I want. I want my way. I'm getting the high values. That's where I want to sort of have. So interesting thing is that if you are working with Creo Simulation Live, you actually do not have access to this. You are unable to sort of drill down to your areas of interest, for lack of a better word. But with Creo Ansys, you can actually go a bit more in depth. You can create surface regions and go and just minimize those areas with your local mesh refinements. Like the mesh refinements are not limited to just what you call this, to just edges. You can actually go and create surfaces that you want, and then from those surfaces you get that. All right, so there we go. The value is shot up to 202. So this is something that you don't get from Creo Simulation Live. This is the fact that you are able now to find what do they call, sorry, English has sort of disappeared there on me, but it's basically you are now able to identify when you have areas of similarities in terms of how you set up your model. So for example, in this case, it was running around 50, which is basically the ballpark of where I was playing around. But for the actual information now is now revealing to me that actually where I'm looking is a singularity, and I need to sort of come up with a different way. I used to sort of now come in and what you call again this thing and constrain this model. Yes, I'm sorry, the data bundles for English terms run out every now and then. So basically, that is what high fidelity is all about, is that the information that you get from the low fidelity one, you are able to drill down on it and get much more accurate results in terms of how your model actually performs, and if whether that value is actually not a value that you is actually not depiction of the real life stress stress, yeah, real life stress. Maybe one thing that we should acknowledge too is that unfortunately, unlike Creo Simulate, we do not, because what you would need to do now here is actually go and isolate that area, and then you sort of can find the different things. So what I can do rather here is now go to my advanced results, just change the values, just sort of say, okay, um, is that on? Yeah, that's on. I estimate that my force here is around 80. Not my force, rather, my, what do you call this thing? My stress, yes, my stress is around 80. So I can actually come and see, okay, so at 80, where am I exactly? Do you see? It's the area outside of that specific point. Maybe I want to go a bit lower and say, okay, where is 50 at? And then it goes and removes those areas to say, no, anything within this gap here is beyond the specified value that I have there. And then, of course, you can take it from there in terms of how you change or how you fix your model, depending on what it is that you really want to communicate. But what I want to communicate here is that what you get with the high fidelity, is that you are actually able to cover your bases. Maybe just something for just a show and tell is that I had run a different one here, and then I had the mesh controls all the way to 25. And maybe what I just want to show you here is that you can actually now generate a mesh for those low value, and then you can actually have a look at that, and hopefully this communicates the power that is created with Ansys. Well, for now, this one is just a flex to say how far can you go with in terms of your meshing. Like, it's a bit overkill maybe for this model, but to demonstrate how far you can actually go with this, it's actually a good example. Let me see if I can afford. All right, so 30 seconds is done, and can help you with that mesh. Almost black, and there is a lot of elements in there, and of course we can quickly have a look at our diagnostic, and from 8,000 elements we have gone to 100,000 elements, which is all right. It would be nice if I could simulate for you an assembly just to show you how those contexts behave, but for the sake of time, we'll end it there. For those that need further information, they're welcome to contact us for a trial of Creo Ansys and sort of test it with your own data to see how much it is that what it is that it will give you from your side. All right. All right. Thank you.
All right. Thank you for all of those in attendance. Just wanted to run through again. If you do have questions, we do have a Q&A section. Please be reminded that the video has been recorded. I see a hand, and so what I think I will do is that it might be easier if I just kind of unmute anybody who has questions. We'll just give you a chance to have your say and ask your questions, and then we'll deal with it. George, you are the first. What is your question there?
Thank you, sir, for the presentation. Might have been slightly, late to get in because I think connectivity issues and all that. But I just wanted to find out. I see from the demonstration You're dealing more with structural elements. I'm from the civil engineering part, so anyway, steel components would still be part of our structural elements. But now I'm thinking of an assembly, figuratively. Let's say you look at a foundation and the superstructure as an assembly. Now, can that be handled by this tool? Just to find out, I'll do a finite element analysis on an assembly, assuming a superstructure and the foundation as one assembly. Let's say I want to look at the settlement and which points will settle faster, differential settlement. Which parts would crack on the superstructure, and something of that sort. I'm thinking slightly different from the current presentation that you've just given. Just maybe like Plaxis works. Of course, Plaxis works more so for soil components and foundation analysis. Is it possible that this can do that?
Okay, all right. So as I've mentioned, in terms of complex structures, yes, you can have your superstructure going up and analyze that, and of course, as it gets more complicated, much more detail and time that will take. But in terms of soil analysis, I don't think it's specifically designed for that. We don't have a section where you are analyzing how soil sort of behaves. It will be interesting to see if you can actually create a model and sort of simulate soil, but as for specific soil or concrete for that matter, I don't believe that it's capable of doing that.
I was thinking of soil, as a foundation, component in itself. Once it's been constructed, of course, now it becomes more or less like a one component, though an assembly. But as you say, the model might not be able to do the various site of settlements and the weakest points within the foundation that may need more reinforcement. But the superstructure, you say it can do, but the foundation together with the superstructure, it might not be able to do.
Yes, assuming you say superstructure, you mean it's a steel structure.
Okay, mostly a C structure. Okay, that's fine. Thank you.